Instead of just marking data as missing, we can also use several techniques to fill it in. Welcome to another MetPy Monday. Hello, I'm John Lehman, a software engineer for NSF Unidata. This week we're going to wrap up our discussion of dealing with missing data by talking about how we can fill data in instead of just mark it as missing. And this can be really useful if you need to keep all of your data rows and you have a field that can be filled in some scientifically reasonable way. So first, let's look at another field in our data, which is temperature. Now, if you don't have this data, be sure to go back to the beginning of our missing data series and learn how to read it in. Okay, I'm going to start out by making a disk plot of our temperature. And we see some interesting things here. We've got these generally normal shaped curves, but some very big gaps in the histogram or the distribution plot, and one clear outlier where we've got a lot of values that fall there. So let's dig in just a little bit deeper maybe. And on our temperature, let's call the describe method, see if we can learn anything from that. So we see our count, mean, standard deviation, minimum, maximum, and nothing really stands out there. But I want to know about this one spike. Is that real? Is that some value that's being used for missing data? What's going on there? So how can I know where that is? Well, I can use the counter object from collections. So from collections, I'm going to import counter. Then I'm going to create an instance of counter on our temperature data. And I'm going to call the most common method. I want the first most common thing. And with 16,363 entries, it is 32.0 degrees Fahrenheit, which should ring a bell as the freezing temperature of water. So is there a reason that that is such a common value? Well, we know that when water is freezing or melting, it's going to buffer at 32 degrees. So that makes some sense. I'm a little surprised the spike is that high, but that's an interesting observation. Now, as far as why there are these dips in certain values in the distribution plot, well, that's another story for another day. And that's because today we want to talk about how to deal with missing data in terms of filling it in. I need some sort of continuous calculation field, and I can't give up any of my rows, but I don't want to just have an NA. So what can I do? Well, first, we need to see if we have missing data in our temperature field. And there are several ways you could do this. The quickest is going to be to take the length of the index and subtract the output of count, because count only counts non-NA values. And we see, for example, there are no valid times that are missing, but we have 1,648 temperatures and dew points that are missing. So this is a candidate for us to use filling on. Now again, you have to consider the scientific objective that you're trying to achieve, and if these methods are valid. But I want to show you three really quick and easy methods that you can use. The first, we're going to create a new data series, call it ffill, and we're going to take our temperature data and call the ffill method. It's that easy. What this is going to do is forward fill. So if our temperature is, let's just give a time series here of something like 32, 33, missing 35, it's going to take that 33 and just run it forward until the next valid value. So it'd be 32, 33, 33, 35. And that could be a valid thing to do. Depends on your time step and if you expect your process to be more influenced by the past values or not. Likewise, I'm going to copy that twice. If one method is forward fill, you can probably guess the next is backward fill. So here our sequence of 32, 33, missing 35 would come out to 32, 33, 35, 35. It's going to backfill. So this is if you think that the variable or the number that's missing will be more represented by the number that comes next. And finally, we can interpolate. And when we do interpolate, it would do the 32, 33, 34, 35, 36, and so on. It's going to take those two values that are on either side of your missing value or values and interpolate in between evenly. So it's not going to be time aware, nothing like that. It's just going to be even interpolation. This could be great if you expect or know that you have strings of missing values. For example, if my temperature sensor was broken for a month in my data, I probably don't want forward fill or backward fill, and I may not even want to interpolate. That's one of those situations where you have to think about what the most valid thing to do is. But what if my temperature sensor was broken for a few hours? Well, interpolate's probably the right answer. Okay, so let's make sure that our filling worked here. We're going to rerun this same method, and we see that forward fill, backfill, and interp all have 0 missing values now. So that did indeed work. And if I want to see, I'm going to import matplotlib. .pyplot as PLT because I want to make some simple histograms. We're going to make our histogram of temperature Fahrenheit, bins. If we look at our describe, we know we go from -13 to 104. So we'll just make 1 degree bins. Make sure we have everything spelled right. I'm going to put a semicolon to suppress that print output in the notebook. Okay, there we get something that looks like our dist plot. And now I'm going to add our forward fill, our backfill, and our interpolated. And that may not be, we can see there are some differences for sure, but we could add an alpha argument here. So we'll leave our original data dark because we know it's going to have the lowest counts because it has missing data. And again, yeah, we don't see a huge difference, but we can see the difference between forward and backfill in these colors, and interpolate doesn't really show up as we have very small bar differences there. All right, so I hope that you found this series on how to deal with missing data useful. As scientists, it's a very important skill for us to be able to recognize missing data or recognize quality problems in our data and be able to deal with it in a statistically valid and scientifically sound way. I'll see you on next week's MetPy Monday.